Okay, hello biology, this is Mr. B, and we're going to start off the year talking about Chapter 1, and the title of that chapter is The Science of Biology. So we're going to take a look at why biology is considered to be a branch of science, and kind of the ins and outs, everything biology related that's going to really come up in this class this year. So it's going to be, in this chapter, kind of give us a little introduction, and then it's going to give us a big overview of what to expect for the rest of the year. And so the title of our first section that falls within Chapter 1 is called What is Science? So to start, we're always going to start with some questions to think about that kind of are going to play a role throughout each section. So one of our questions that we're going to think about are, where do plants and animals come from, and how did I come to be? Again, these are really big philosophical questions that a lot of people ask, and humans, if you look down there, have tried to answer these questions in different ways. Some ways of explaining the world have stayed the same over time. Science, however, is always changing. So there might be some people that, I don't know, maybe 200 years ago had a view of where plants and animals came from that was different from how it was 200 years before, 200 years before that. And now, again, here in the future, it is always changing as well. And if we didn't change, then again, we probably wouldn't make any of the advances that we have today. And science is a big part of that because it is always changing. It is never stuck in the same place there. And so then we're going to look at what are some of our goals of science. So our first goal of science is to provide natural explanations for events in the natural world. So that is probably one of the most important things I can stress here, is that one of the goals of science is to provide natural explanations for events that occur in the natural world, and then it aims to use those explanations to understand patterns in nature and to make useful predictions about natural events. Now, when we say the word natural, it's mentioned at least 3 to 4 times just in this one sentence. It's things that fall within our earth that we can see, that we can touch, that we can feel, that we have concrete evidence about. That's what it means when we say natural world. So things like the boogeyman, Bigfoot, Loch Ness Monster, until someone has actual concrete proof that any of that stuff actually exists. Again, ghost hunters is a big thing. They try to apply scientific data, which again, really, there has been no consistency in any of those things. So those aren't things that we talk about when we think of science, and that is because they do not fall in the natural world. So natural is a big thing here with one of our first goals of science. And so for our next one, it's going to talk about what biology is. So biology is not just a collection of never-changing facts or unchanging beliefs about the world. So biology, again, falls within our natural world. So it would be kind of irresponsible for us as scientists if we just kind of memorized different things about how different things worked and just were able to regurgitate them back to me, because I can guarantee what you're learning right now is not the same thing that your parents learned, and it's not the same thing that their parents learned before them. So biology is always changing, and so we kind of have to keep that in mind. So some scientific facts, again, that we consider to be facts today, they will change very soon if they haven't changed already, and scientific ideas are open to testing, discussion, and revision. So science, and biology included, is an ever-changing thing. So don't think of this class as something where we're just going to have to memorize a lot of stuff. You should really think about it as a way of changing the way you view the world, and the way you think, and the way you go about and handle yourself. And so then again, we've mentioned science a bunch actually in this chapter, or in this section so far, and now they're going to actually finally give us a definition of science, saying that it is an organized way of gathering and analyzing evidence about the natural world. So again, natural coming up there. So for our example is that researchers can use science to answer questions about how whales communicate, how far they travel, and how they're affected by environmental changes. So again, that is just one example of, again, a huge array of choices, but they just use that because, again, there's a lot of different science and technology that goes into figuring these things out. How the whales communicate requires some very sophisticated equipment that, again, science has paved the way for. Again, how far they travel, little tags that we can put on them, and how they're affected by environmental changes. and that is the only true biology one there, because we actually study their body and how it has affected them. But again, these others are done using things that are more kind of physical science related. And then again, we keep coming back again, talking about more about science, is that it only deals with the natural world, and scientists are going to collect and organize information in an orderly way, looking for patterns and connections among events. And the big thing with that is patterns. So we always want to try to explain why things occur, and the easiest way we can explain why things occur is by looking at patterns in nature. Do these same things happening over and over and over again? The same things are happening over and over again. That probably means they have the same cause, so we can kind of develop an idea to explain why that is happening. And then a big thing with scientists, again, can't stress this enough, is that scientists propose explanations that are based on evidence, not on belief. So you can't really come in with your own ideas and expect to prove what you want to prove and be a successful scientist. And again, you test these explanations with more evidence. You can't just have a way of thinking because that's how you feel. You have to really be in touch with what the facts are and what the evidence is actually showing to you. And so then now we're going to get into some more of our goals of science. So the first one is that the physical universe is a system composed of parts and processes that interact. All objects in the universe and all interactions among those objects are governed by universal natural laws. So again, there's different things. We talk about a theory and a law. Laws are things that we know are going to happen. So within our universe, there are certain laws that have to be followed. For example, if I drop a pencil on the ground, it is always going to fall. It is never going to shoot back up and shoot through the ceiling and go outside and fly off into the sun. That is a law. We know gravity will pull that down, and there's other laws within our universe that are going to govern how things act. And another, again, goal, which we've mentioned this about the 5th time, so I'd say this is probably important, is we have to provide natural explanations for events in the natural world. Again, until someone can give me concrete evidence that Bigfoot exists, someone catches one, can show me others, again, we can't consider that to be something in our natural world. And then we also aim to use those explanations to understand patterns in nature and to make useful predictions about natural events. Again, that is a huge thing. We have to find patterns because, again, we can then, once we find a pattern, we can maybe predict how things are going to act in the future, and then we can maybe proactively solve a problem that might be coming up. However, because we have all this scientific knowledge, much of our nature does in fact remain a mystery. Almost every major scientific discovery actually ends up raising more questions than it answers, so this constant change shows that science continues to advance. So I wouldn't worry about writing all of these things down here. I would maybe more just pay attention to these. So learning about science means understanding that we know and what we don't know. Scientists rarely proves anything in absolute terms. Scientists aim for the best understanding of the natural world that current methods can reveal. And as we go in here, as you're going to notice throughout the year, we're going to maybe learn about, like, well, in some cells, this organelle has this function, but there's always going to be an exception to the rule. So we never actually prove anything in absolute terms. We can kind of just get a main big overview, and it has allowed us to build enough understanding to make useful predictions about the natural world. So again, we do have a lot of evidence, but like we said, nothing is 100% true. We are all living things. We're always changing, and that's kind of one of the beauties of biology. So that's it for our first part. Let me know if you have any questions.